early in the morning, and all you can hear is bow wow. It's your little puppy. You look at the time, and it's 6 a.m. What? You could have slept in. But you still love your puppy, so you go feed him his favorite type of food. What if I told you Lazy Dogzz has a very specific invention just for you? It's the mechanical dog feeder. This is a set of integrated circuits, a stepper motor, and a pressure sensor that are all used in combination in order to give you your time back in the mornings and its afternoons. By using the little paw of the puppy, it presses down on a pressure sensor which dispenses the food automatically given that certain parameters are met. You as the owner know that your time is valuable. So all you have to do is once every 2 days, lift up the top nice and carefully, fill in the food into the slots, and then if you want to be nice, you can give them a little treat. But this is a mechanical dog feeder. We're trying to give you your time back. We know that your time is precious, and so this saves you time. It's gonna be great. It's coming to a store near you. Now let us tell you about our contraption. Here we have the housing itself. It's pretty self-explanatory, but it uses a rod and flaps to spin the food around. On the bottom, we have a stepper motor. The stepper motor was the best for our application as it would give us the most control based off of the Arduino. Next to it, we have the motor mount itself. The motor mount was pretty self-explanatory, but it gave the top of our mechanism a nice sleek view as well. Next to this, we have the base of the system itself. It's elevated so you can put the dog bowl under it, but it also contains the tabs where you could place the top housing and prevent further torque from turning it. This is the housing itself. It's pretty nice and sleek looking, but it gave us a nice product where the two holes in the bottom would be where the rod runs and where the food falls through. It looks nice overall, and our customers would really appreciate that. Next, I can show you how the turbine actually works. When you push on the pressure sensor, we can actually see it turn. We can set how many turns or how much it spins based off the Arduino, but we got it to work very well based off the pressure sensor. Now I can talk about the electronics of this system overall. Here we have our Arduino, and it's connected to the H-bridge, and over here we have our resistor circuit. The most important thing of this circuit overall is the H-bridge, in which all the ports from the H-bridge are connected to very keen things on the Arduino. In blue we have the power, and we have red and power from the 5-volt, but we have the white ones coming from the digital outputs of the Arduino. Those are very important. And over here we have a simple voltage divider, in which it was used to read the force sensor that we had. Over here in our H-bridge, what was most important to consider was how we connected the wires on the left side of the H-bridge. This was very important because it's a bipolar motor, so it cannot work unless the correct wires are in the correct places. Overall, we have our power running around as well as our common ground, which gives us this circuit that is integrated that would be useful. Now I can explain the pressure sensor. It's very simple to understand, but it's just two pieces of foam core with a spacer inside it. Here, we can compress it and it will read the force accurately. But what's important to notice is that we only have 3 screws overall. This was very important because we have on the top, left, and bottom, but not on the very bottom left. This allowed us to compress one side a little bit more and give us a better accurate reading. But unscrewing the buttons, we can see that our pressure sensor inside, and we can see that there was very keen electrical connection made there. But we can also notice that there's screws in the middle. These provide spacer. So technically when you compress it, it can spring back up so it can read the pressure sensor correctly. And for our top flap, there's nothing really special about it, but we did use a coin to give a better pressure reading when it was pushed down. Now I can explain the code. Here we have many different things going on. But one of the biggest things to notice is the actual RTC. This is one of the things that we're gonna buy, but it came in handy knowing that the Arduino had one. Here we define some variables which we'll need later on. And then we can see that the false was actually very important as it makes it possible for us to look down here and see that after a certain amount of time, if there's a pressure felt, then it will turn the E to true, and then that will then turn the motor, depending on what time of the day it was. Since up here we can decide what time it is, and most of the time resets to 12 o'clock. But overall, we get a measuring system that will then turn the 33 steps if it is true. Here we can just see the pressure sensor working, and when we actually push on it, we can actually see the pressure jump up from our pressure plate